All right. Jada, so I went through your work, the worksheet 6. I think you don't have any problem. So I want to go over the worksheet 7 with you, through recorded video, then I'll send it to you so you go through it. So the first question of worksheet 7, I think that one you didn't do that well, but it's okay. So first one, you were asked that three resistors are connected as shown below, and the values are respectively provided for the various ones. So they were provided with the A1, V1, R2, and V4. Now the first question you are asked, what is the reading of A2, which is this one? And I believe we both did it, that since both of them are here, the same current is going to pass through them. So if we know the value of A1, we know the value of what? A2. So therefore I can say that my A1, or they ask for A2, so my A2 is the same as A1, which is what? 4 ampere. What's the reason? So you explain this is because they are both on the same branch, hence same current will pass through them. All right. Now the next one, you were asked that calculate R1. So R1 is just one device, and I told you that just pick the device. So this is R1. So if you want to find R1, this one we are applying Ohm's law. So if you want to use Ohm's law, as you already know, that is V is equal to what? IR. So that's what you are going to apply here. So if you want to use the triangle, let me draw the triangle here, so that I'm going to refer to it to help you do it. So I have my V, I have my R, I, and my R. So now you are asked to find your R1. So if I'm finding the R1, what do? I'll cover the R, that becomes V over I. So that's going to be my R1 is going to be what? V over I. But because it's it's R1, I'm going to use the V1 and the I current that is passing through. So that's going to be all right. So looking at this particular part, you see that the voltage across this one is the V1. So you can choose to put V1 here, or just so on that particular device. So that's what you should always check whenever they give you the circuit. I told you that you can solve for individual devices. I remember I told you this, and you can solve for the entire circuit. Remember that when you are solving for the individual circuit, you take away all the measuring instruments. What are the measuring instruments? The ammeters, the voltmeters. They are all not part of the actual instrument. So here, what we are doing is that we are considering only the R1. And if you are considering the R1, we are using the what? The Ohm's law, which is what? V is equal to what? IR. But here we are finding our R, so we cover the R and become V over I. I hope you understand. So now that we have it, so if I want to find my R1, I'll need my V and I'll need my I. So you go back to your question to find those values. I need my V. So what is the V of this? The V of R1 will be what? The V1. So you can just put it here that my V is a V1. And then your current, that is I, will be what? This is the current that is passing through. That is the what? The one in A1. So what is the A1? Which is 4. Okay, so let's write those values down. So the v1, so it's going to be the v1 over the a1. So the a1 value is for the I. Okay, just to make you remember that. So my v1 is given here to be 10. So I'll write it down to 10 volts. Then my I, which is the current that will pass through that particular device only. So it will go, this one will come and pass here. So it's the same thing that will be here, that will pass here. That is 4. So I write it down, my 4. And when I divide these two, what do I get? I get 2.5 ohms. That is my R1. I hope you understand. Let me go over it again. So what we are doing is that we want to find our R1. And I told you that in a circuit, you can evaluate or analyze them device by device. So whenever they give you a circuit, use a pencil or something to cross out all the measuring instruments. Okay, you can choose to redraw the whole thing again and neglect the measuring instrument. Then you consider only this, only this, only this, and the entire circuit as a whole. So per this question, what you are doing is that they ask you for R1. So you come to the circuit and identify your R1, which is this. After that, you need to find the value of R1. So always you are applying Ohm's law. Always, mostly the circuit, you're always applying Ohm's law. So now that you say find R1, you go to your Ohm's law chart. Finding R1, you need was voltage over the current. So you write them down. Then you come to the circuit again. Then since you need the voltage and the current that passes through that device, you search for them. So looking at here, the voltage that across this one is the V1. So you come here, the V1 is what given to be 10. So you write it down. Then what current will pass through that particular one? It wasn't given straight away that I, but you know that A1, the reading of that is the current that is passing through all this branch. So that will also be what? The A1. That's what 4. Then you divide it to get this one. I hope you get it. So the same thing, similar one. They said find what? V2. V2 meaning you are going to what? The device R2. So this is the device that you are looking at. But this time they said find what? V2. So saying if you are finding V2, come back to the Ohm's law and apply. If I'm finding my V will become what? I times R. So let's write that one down. That my V2 is equal to my I times R. Okay. But which R are we talking about? You need to specify. So realize that here I specify the V here to be V1. So seeing your current or your resistance, you need to verify classify them. So here looking at the diagram here, for where the V2 is, the main thing is what? R2. So you can just put it there as what? I times what? I times R2. So since the same current is passing through all of them, see the same current, so the same current will be the same 4 throughout. So this current will also be what? 4. So my V2 becomes my 4 times, now what is your R2? Go back to the question, what's the R2? R2 is given to be 1, which is equal to 1. You multiply the 2, you get what? 4 volts. This one you got it correct, but I just decided to write it again for you. All right, now the next thing to do is what we call, is that you should determine the value of the V3. So the V3, there are two ways of doing it, but the easiest way is what you are supposed to do. You can choose to pick only R3, only this device, okay, but you get stuck. Why am I saying you get stuck? Let's look at it. So you get it. So if I take that one, I'm finding V3. I'm finding V3 is going to be equal to what? V3 is equal to I times R3. So meaning I need I and I need R3. So fine, from the question I have my I, which is 4, because the same current passing through. But do I know the value of R3? There's nowhere, they didn't give any value of R3. So I can't solve it. which will be a what? A question mark. So therefore, this method, you're not going to use what? This method. So rather, there's a different method that you are going to use, which I mentioned the last time, that if I have a dry cell, an individual circuit. So let me just put it here. Let me use that note. So note this. If I have this resistor, this resistor, this resistor, okay, let's say R1, R2, and R3, and each of them have their own voltage. So this one, let's say this one is V1, this one is, let's say, V2, let's say this one is V3. Okay, now if they ask you that what is the total voltage across them, that is, let's say, V4, what is the total voltage across them? Simply, if you have to find V4, is simply adding them. So your V4 is equal to V1 plus V2 plus V3, and I hope you get it. So always when they are in series, we add the individual voltages. So the voltage around across this is equal to the total, and always the total one is also equal to the EMF of the cell. Please, I hope you get it. So that is for series. Please, I hope you get it. Always the total voltage is always equal to the EMF, but for series it's equal to the sum of the individual voltages. I hope it's clear. Let me put it here that this is for series. Okay. All right. Then for parallel, let me do for parallel too. Now for parallel, let's say I have this resistor, this resistor, this resistor. Okay, now we believe that now because all of them are parallel, they are going to have only one voltage. Okay, because they are all parallel, they are going to have only one voltage. So mostly what they are going to do, they will try to confuse you. So they are going to put something here. Let's say V1. Let's say they will measure this one too. V2. Let's say they will measure this one too. V3. Okay, and they ask you to find the total voltage when they are in parallel. When they are in parallel, you don't need to bother yourself. All of them are equal. So your V1 will be equal to V2. It will be equal to V3. It will be equal to V4. Okay, it will be equal to V4, which is also equal to the EMF. That's for parallel. So for parallel, whenever all the resistors are in parallel, they all have the same voltage throughout, and that one is also equal to the what? The total voltage, which is also equal to what? The EMF. I hope it's well understood. All right, so now with that in mind, let's solve this question. So I have this one here, which says I should find my V3. Now you see from the diagram that V1, V2, V3, and there's V4. Now from the question gave us V1. We know V1. We solved for V2, and we know V4. So we can find what? V3. So how do we do that? So I can say that my V1 plus V2 plus V3 is equal to what? V4. What's my V1? It was given to be 10 plus my V2 we calculated to be 4 plus my V3 is what you are finding, and my total is what? 18. Solving this, you get V3 to be what? 4 volts. So that's how we solve this kind of question. And now you're asking you, what is the EMF? What do I say EMF is? The EMF simply the total voltage of all of them, not the 4. The 4 is not total. So you see that the 4 is across all of them. So the 4 is what we call the total. So therefore the 4 V4 is the same as the EMF. So what was the V4? It was the 18. So that one will give us, so the EMF of the battery is also what? 18 volts. Okay, let's see the question, problem 2 here. But I hope you understand the problem 1 in worksheet 7. All right, just take your time to go through it, and I'm sure by grace as you'll be able to understand. Okay, V2. It says 3 identical light bulbs. That's a key word. 3 identical, meaning everything, if you know for one, you know for all the 3. 3 identical light bulbs are connected as shown below. So we have this light bulb, this, and this. If the battery has an EMF of 5 volts, so this battery, the EMF is 5 volts. Let me write it here. It will help me so that I don't go back to the question. Of 5 volts, and the resistance of R1. So meaning the bulbs have resistors inside them. We call them internal resistors. Okay, just internal resistors. And they said for one of them is 2 ohms. So meaning for this one is 2 ohms. But remember, they said they are what? Identical. So just fast, you just do that for the other ones, so you don't get confused. All right. Now that you have the preamble down, what are they asking you? They said calculate the what? Equivalent resistance in parallel. So these two are parallel. These ones are parallel with this. So this one, I know that's very easy for you, so I'm not going to waste time on it. So I just find the one in series. So R in series will be R1 plus R2, which is what? 2 plus 2, giving us 4 ohms. And that is also in parallel with the 3. So therefore my RP is equal to 1 over the RS plus 1 over R3 is going to be 1 over what? 1 over 4 plus 1 over 2. Okay, this is going to give me 3 over 4. All right, I'm going to turn. What I do now is just turn both of them. So I'm going to get my answer to be RP equal to 4 divided by 3. And what's 4 divided by 3? That's going to be 1.33. 1.33. Since its resistance is going to be ohms, so this will be our value for our resistors in parallel. I know this one is easy. Okay, so let's see for the other question. They said we should find our A3. What is the A3? A3 is simply this one, and that's the total current, but there's the current coming from the dry cell directly. Okay, so we should calculate that. So since the A3 is the total current, I always told you that the current that is always coming from the dry cell, the total current, and that's represented by the A3. So if I'm to find the A3, whenever you are finding total, you are going to use everything total. So if I'm to find total current, meaning I'll need total voltage and total resistance. Okay, that's what you should always know. So let's look at how the 3 are related using our Ohm's law here. So if I'm finding current, it's going to be voltage over resistance. So therefore I'm going to say that my current, the total is going to be voltage, that is total, over the RT. Okay, let me write it at this place right there. So my IT is equal to VT over RT. Now, what's the total current? What total voltage? You say the total voltage is always equal to the EMF, and they give the EMF to what? The 5 volts. So what is it going to be? It's going to be 5 volts here. Total resistance is what you've calculated above. They said the equivalent resistance. So that's the total resistance. That's 1.33. When you evaluate these two, what do we? So we are going to get 3.75 ampere. So that will be our value for A3. Okay, all right. I believe you'll be able to understand this. Okay, so let's move to the next one. Here they are asking, is A1 equal to A2? So let's see. So let's find out A1. This is A1 and this is A2. They are asking, are they equal? And explain. So you see that's from the total, from here the total, when it gets here to divide to here and here. But they're asking if they are total. So from this you clearly see that they are not equal. Why are they not equal? You see that the total resistance at the top, this one is just two resistors that are stopping the current. And this one has only one. So you see that since this one has only one, more current will flow through this one than this one. Okay, more current is going to flow through the one that has, remember I told you that less current, less resistance means more current. Okay, and more resistance means what? Less current. They are always indirectly proportional. So the ones that have more resistance will have less current. The one that have less resistance will have what? More current. And the resistors are not the same, so they can't be what? Equal. So let's write our answer. So what can we say here? Say that are they the same? No. Okay, A1 is not equal to A2. Why? This is because they have different resistance in their branches. Okay, different resistance in their branches. I believe you understand what I just said. All right, let's move to the next one. It says calculate R3. So you calculate your R3. So let's see, where's our R3? Calculate the current, calculate the current through R3. So here, there's our R3. What's the current flowing through? That will be this. So that's what we want to find. Okay, so let's see. Using the Ohm's law, we are finding current. I'll cover this one. Going to V over R. So let's come here. So my current is going to be V over R. So what do I need? I need to find my V and I need to find my R. But my R is the R3, so I can write the R3 there. Let's go and find our V. So you see, how do I find my V? There's no V that was written here. But remember when I explained with the notes from what I drew somewhere here, I said whenever they are in parallel, okay, all the voltage are the same. So the voltage, total voltage is the same for this, it's the same for this. So the EMF that is 5 volts is the same for this, is the same for all of this. So therefore the voltage here is also what? 5 volts. Then the resistor R3 is 2 ohms. So that will be here. When you calculate, you're going to get 2.5 ampere. And that will be your answer. Okay. Alright. So let's see question 3. I think that was the last one. Alright. So they said 3 resistors are connected as shown below. Values are respectively provided for. So these are they provided R2 total voltage, they provided a total parallel voltage, and the one in A3. All right, so let's see what will be the reading on V1. So let's see, this is our V1. So they're asking what will be the reading on V1. All they know they are trying to do is they are just trying to confuse you, but it's normal. You remember I said that whenever the resistors are in series, the sum of their voltage is equal to the total. So looking at this, you see that VP and V1. So the VP is for all of this. So all this is a VP plus the voltage around this will give you a VT. So I can be able to find what my V1. I believe you get it. So here you can say that your VT is equal to VP plus V1. Right? And know your VT to be what? 3. And your VP to be what? To be 2 plus what? V1. So therefore your V1 is equal to what? 1 volt. Okay. Now why? Explain why. So as you can say that in series connection, in series connection, the sum of the voltages is equal to the EMF or the battery. Alright, as simple as that. Alright, now let's find R3. Where is R3? So we locate your R3. So R3 is here. Now to find R3, same principle, Ohm's law again, and it's what you're finding R, so it's going to be V over I. So let's write it down. So my R3 is equal to V over I. Which V are we using? It's supposed to be V3, and the I is the one for the A3, as you can see there. So the A3 is be the R3. Now let's find them in the question. Where's my V3? Was a value of V3 given? Let me check here. It wasn't given. But you know that I told you that whenever they are connected in parallel, so just only consider this one now. You see that this one here is in parallel with this. And if they are in parallel, then it means all of them, they have the same voltage as the total voltage here. So they said VP, so it means VP, voltage of the parallel. So this VP is the same as a V3, the same as a V2. That's the trick here. So my V3 is the same as the VP, which is equal to what? My 2 volts, right? And my I3 is the same as A3 was given to be 3.33. When you calculate that, let's see what you're going to get. So I have my 2 divided by 3.33, giving me 0.6 ohms. Okay, 0.6 ohms. All right, let's look at the next one. Let's say we should find A2. A2 is this one here. So if I want to find A2 is for current. So I come back. I want to find current, is going to voltage over resistance. So A2, that's same as I2, is equal to voltage 2 over resistance 2. So So let me see if I have information of voltage 2 and resistance 2. So I come. Do I know V2 exactly? Because you know that everything, since they are all parallel, this, and this are equal. So you're same as VP, which is equal to 2 volt. What's my R2? Was the R2 given? Yes, it's given here to be what? To be 3. So I have 2 divided by 3. That's going to give me 0.67 ampere. Okay. All right. Then you need to then find your A1. Now, what is the A1? A1 is what I told you, the current coming from there, directly from the dry cell. Is a total. So since it's the total, what do we do? You see that is a total, so it will come here, pass here. Then the same thing that is passing through this one, it will go here and here, come back here and pass here and go. So we have our A1 here. It will be the same current that will pass through this, if you agree with me. Forget all the measuring instruments, okay? The A1 to pass here. When it gets here to divide, then to get here, then come and pass. But when it gets it to join again to pass through this. So the A1 here will be the same thing that will pass through this. So we see that if I consider only this, I can find my what? A1. So I'm considering only this. So if I'm finding A1, where is the current? So it's going to be current 1, which is I1, is going to be same thing. It's going to be V1 over R1. What's my V1? This time my V1 is this one, which we found before to be 1. Is equal to 1 over, what is the R1? Was the R1 given? R1 was not given, so we can't use this formula to do it, and that's how the circuit is. Sometimes their formulas are different, so we have to find a different method to solve it. All right, so let's see how can we then find our how can we then find our A1? To find our A1 here, then now instead of doing for this, we can solve for all of this, only this. Okay, we consider only this one. It will also help us to find A1, because that A1 will be shared among these two. So if I find the total resistance here, I'll be able to find it. Okay, so inside this one, what will be the total resistor? Because this one and this are parallel. So let's try and solve that one. Let me create a space here to do that. So I have my R parallel is equal to 1 over R2 plus 1 over R3, and 1 over R2 was given to be 3 plus my R3 was given to be, we calculated to be 0.6. So I solve these two and I get my RP to be equal to, which is going to give us 1 over 2 ohms, or 0.5 ohms. Okay, all right, so now that I know that RP, I already know my VP. So I found the VP is given here to be 2, so therefore I can find my current, because that will be the same current as A1. So therefore I can say that my A1, or the I1, is equal to VP over RP, and my VP is 2, and this is 0.5, giving me 4 ampere. You see, very tricky, but it's not far-fetched. You can be able to do it. Now, using that information, can you find R1 exactly? Because you know that the I1 that is here, that'll be the same thing that'll pass through this one. So now you have your I, you have your V1. You can find R1. From the Ohm's law, we know that R1 is equal to V1 over I1. What's my V1 is 1. What's my I1 we found is now to be 4. So when you calculate these two, what do we then get? We are going to get 1 divided by 4, which is 0.25 ohms. And that is what this whole worksheet is about. So you need to apply all the various methods. Physics is kind of confusing, but you should always apply the rules. And if you have the rules, you are good to go. I hope you'll be able to understand. I pray the Holy Spirit helps you and gives you the understanding that you need. All right. Bye.